you can refer to the note before. All right. So this problem is regarding a Frobenius method. Okay. On your test, okay, you must be able to know when to use Frobenius method and when to use the other normal method. Okay, you must be. I won't tell you. Okay, use Frobenius method for this. No, you have to identify which method that you want to apply. Okay, for this one, we have xy double prime, okay, plus x minus y minus 1, y prime minus y equal to 0. Okay, so what is the question? The question is this about x equal to 0, I think. Okay, around x equal to 0. Okay, so you are asked to find series solutions around x equal to 0. Okay, when you see this word around, you can expect this is concerning Frobenius method. If about mean we use the normal method. Around, that means not including this x equal to 0. Around x equal to 0. Okay, that means this is normally this is Frobenius method. Okay, so it's given around x equal to 0. So for question B, okay, first you need to check, okay, x equal to 0 is what? Is indeed irregular singular. Okay, only if x equal to 0 is regular singular, then you can employ Frobenius method. Okay, if x equal to 0 is not a regular singular, which is irregular singular, you cannot use Frobenius method. Okay, Frobenius method you can use if and only if we have a regular singular point. Okay, first, okay, you need to find, okay, you need to prove that this is regular singular. Okay, first you need to find the singular point. You have to transform from here, okay, to this. Okay, you divide all terms with x. Okay, you know that when x equal to 0, okay, both px and qx or either one, okay, is what? Is singular. Okay, it's not analytic, right? So in this case, both are not analytic when x equal to 0. So that means x equals 0 is what? Is singular point. Okay, and then the next step, you need to check whether it's regular or irregular. So we need to construct these new functions. Okay, x minus x naught px. Now x naught is equal to 0. So we have x times x minus x1 over x, because this is px. Okay, you simplify this. We have x minus 1. When you replace x with 0, you have minus 1. I mean, this function defined. You have value, okay, when x equal to 0. Do the same for x minus x naught square qx, right? Replace x naught with 0. So we have x square. Okay, qx is 1 minus 1 over x. So time 1 minus 1 over x. Simplify this, we have minus x. When you replace x with 0 here, you got 0. Still, the value is, we have the value, which is 0. Okay, it's not undefined. So analytic. So both these functions, okay, and this function are analytic at x equal to 0. So we conclude that, okay, x equal to 0, x equal to 0 is what? Is a regular singular. Okay, then only we can employ Frobenius method. Okay, which is, this is the general series for this. Okay, x minus x naught power of r. Okay, now remember, now n start with 0, not equal, n equal to 0 now. Okay, and then cn x minus x naught power of n, replace n with 0. So we simplify like this. Okay, and then when you refer to the given equation, you need to find y prime and y double prime in terms of summations. Okay, so y primes, okay, you do the same thing here. You bring n plus r, okay, in front. then Cn unchanged xn plus r minus 1. But here n start with 0. Okay, before this in the normal method, n start with 1 because we have n here. But now we have n plus r. So this term will not be 0 if n equal to 0. Okay, so the same thing for y double primes. So we have this, we have done this before, and we substitute. Okay, we use all the theorem. Okay, all the definitions. Okay, first we need to bring this x. Okay, x y double primes plus x minus y primes minus y. So you just replace y double prime with this, with the summation. Here y prime and here y. Okay, whatever inside here you need to eliminate. Meaning that you bring this inside. Okay, so that's why become n plus r minus 2 plus 1. So it become n plus r minus 1 because you multiply these terms with x. That's why you have this, right? And then here, since you have two terms outside, so first you have to break into two. The first term, okay, the first summation, you multiply this summation with x, okay, and that's why we have this. N plus r minus 1 become n plus r because you multiply this x with this. Okay, we got this term, and then next minus 1, okay, times this term, you got this, these summations, and then minus y. Okay, and then again the same concept as before. We need to make the power of x the same. Okay, so this one you have to be creative. There is no unique way. Here I want to change to x minus n plus x plus n plus r minus 1. So I replace this n with n minus 1. I replace this n with n minus 1. These, the first and the third summation remain unchanged. Okay, and then every time we see x, n, you have to replace n with n minus 1. So n minus 1, n minus 1, n minus 1, n minus 1. Same thing here, n minus 1, n minus 1, n minus 1. So now the power will be xn plus r minus 1 because this will be x. You just rearrange this, xn plus r minus 1, n plus r minus 1. Now the power are the same, right? The power are the same, okay, but the index are not the same. Okay, this one n start with 1. This one start with 1. The second and the fourth, the second and the fourth summation, while the first and the third one start end with 0. Okay, that's why in the first and the third you replace n with 0 first. So that's why you have 0 plus r, you got r. Okay, 0 plus r minus 1, you have r minus 1, and then c0, x, replace n with 0, you have r minus 1. This one remain unchanged. Okay, and then, okay, sorry, after this, okay, from now on, n start with 1. Okay, so the same thing as the first summation, but now n start with 1 because the first term you replace n with 0. Okay, and now start with 1. The second one remain unchanged. The third one again, you replace n with 0. Okay, so you have minus, okay, 0 plus r with minus r. Okay, c0, so x 0 plus 0 plus r minus 1, so r minus 1. Okay, from now on, these summations start with 1. So you have this, right? And while the last one remain unchanged. Okay, now when you refer to the summation, all the terms, okay, start with the same power and the same index. Okay, the next step, you group these two together without the summations, right? This and this you group together. So this one r squared minus r c naught, okay, x r minus 1. So you can combine this. So r squared minus r, and then this one is minus r also. So that's why you have r squared minus 2r, or r times r minus 2. Okay. From my observation, from my experience in this topic, okay, students always do careless mistake. Okay, students tend to lose a lot of mark in this chapter because they tend to do careless mistake. Okay, please avoid that one, right? So we combine these two, this and this, we have these terms, okay, and the rest remain unchanged. Now we want to combine all the summations, right? We combine, okay, combine this one is Cn and this one is Cn, we combine both. Okay, we combine this and this one, right? So that's why we have this, right? Next, we combine the second summation and the fourth one because depend on Cn minus 1. So you combine these two, okay, these two. You combine this and this, okay, and then okay, now see you combine this. You combine this Cn and then Cn minus 1, the same power, all right, equal to 0. Okay, so this will be 0 if and only if this is the auxiliary equations. Okay, so r times r minus 1 equal to 0. This term must goes to 0, meaning that we have 2r here, r equal to 0, r equal to 2. Okay, the same thing here, all the coefficient must equal to 0. That means all these term, sorry, all this term must equal to 0. Okay, so to 0, and then we can express Cn in terms of Cn minus 1. Okay, and we do this, okay, and then we will get like Cn equal to minus 1 over n plus r Cn minus 1. It's better for you guys to what? To simplify this. Okay, don't leave like this because later on it will become the expression will become more complicated. So better for you guys to simplify this, okay, so that it's easier to deal with later on. All right, now n start with 1. Here's n start with 1. Okay, now for every r, so now r, you have two the value of r equal to 0, r equal to 2. For every r, okay, so you got to express this Cn. Okay, when r equal to 0. And then for r equal to 2, you got another expression of Cn. Okay, in this case, you will get 8y1 and y2. You got two solutions here, right? y1 and y2. Okay, so when r equal to 0, you replace r is 0 here. So this will be reduced to what? Reduce, you replace r with 0. So so you have, okay, you have mark here, r with 0. So here you will get minus 1 over n plus 0. You have minus 1 over n, Cn minus 1. Okay, so do the same for r equal to 2. If r equal to 2, you replace the r equal to 2. So you have minus 1 over n plus 2, Cn minus 1. Okay, for each of them, you need to find the coefficients. Okay, and then n start with 1. So see, when n equal to 1, you have C1. Okay, C1 equal to minus 1 over 1, C1 minus 1 equal to minus C naught. When n equal to 2, we have done it before, 1 over 2 C naught. When n equal to 3, we have minus 1 over 6 C naught. Okay, when n equal to 4, so we have 1 over 24 C naught. When n equal to 5, we have minus 1 over 120 C naught. Actually, when you see this, observe this. This one is 2. This one 6 equal to 2 times 3. Okay, and then 24 equal to 4 times 6 equal to 4 times 2 times 3. So this is 4 factorial. Okay, so actually this one, okay, this one is equal to 5 factorial and so on. Okay, so y1 like this. Okay, okay, you can express this. Okay, you can express this in terms of general form. Okay, because we're dealing with alternating series, we have plus minus, so minus 1 power of n. Okay, this one 1 over n factorial over x power of n. Okay, if you cannot come up with this term, it's okay. Okay, it's okay. But of course, the mark will be less because we have to give some credit to those who got the general point. Okay, if you cannot use this term, this especially you can also only use this, but this one is better. Okay, all right. So again, for r equal to 2, okay, you find C1. Okay, C1 equal to minus 1 over 3 C naught. Okay, when n equal to 2, we have, okay, you substitute here, we substitute C1 with minus 1 over 3 C naught. We have done this before, so this one will be 1 over 3 times 4. Okay, and then when n equal to 3, C3 equal to minus 1 over, okay, 5 times 12 actually equal to 3 times 4 times 5, right? And then when n equal to 4, C4 equal to, actually this one will be C naught over 3 times 4 times 5 times 6. Okay, before this, I don't write like this. Okay, so it's hard to get the general form. So thank you for Li Ting because she asked me this question. Okay, so try as much as possible to express in general terms. Okay, when n equal to 5, C5 equal to minus 1 over 3 times 4 times 5 times 6 times 7, right? So actually you can write this. Okay, you can write like this, and then you can, okay, express this in general form like this, right? But now n start with 2. Okay, we want n start with 0, so you replace this n with n plus 2. So that's why here you have n plus 2 there, because we want n start with 0. Okay, why? Because in the previous one n start with 0. So here you want start n with 0. Okay, we try, right? We try, and then now, okay, so you got to replace this n with n plus 2. Okay, I mean n minus 2. Sorry. Here, n plus 2. Okay, n plus 2 equal to 2. That means n equal to 0. Here we replace n with n plus 2, n plus 2, and n plus 2. Right? So we have this general term. Okay, before this we didn't get the general terms. Okay, this one is much better. So now you replace, okay, y equal to a y1 plus b by2. So a times y1 is, you can express like this. Okay, and then b, actually this one should be, okay, and then b, okay, b times c naught. Okay, b, so this one is y2 equal to this. Okay, and when you multiply a c naught equal to d, okay, not equal to e. So this is the finance. Okay, in this one in terms of what? General form. Okay, general form. So the key point is that we are trying to get the general form as much as we could. Okay, so we have this, right? Okay, for extra problem. Okay, again here near x equal to 0. Okay, it not necessarily equal to 0. It can be anything here. It can be 2, it can be 4, it can be 100, it can be anything here. Okay, but for the sake of for explanations, okay, to make it clearer, we consider x equal to 0, but not necessarily so. So again, okay, again we have to prove that x equal to 0 is what is regular singular. We do as before. So we divide all terms with x. Okay, that means from here we know that qx, px equal to 2 over x, and then qx equal to 1. Okay, qx is constant. Okay, qx is constant. So now, when x equal to 0, px become what? Become what? It's not analytic when x equal to 0 is undefined. Okay, so x equal to 0 is what? Singular point. Okay. Either one, not both. Okay, either one not defined. So that the value of x is what? that make the function undefined, either one of them is a singular point. Okay, now when x equal to 0, okay, so we have to construct this function x minus x naught px, replace x naught with 0, okay, then x px, x times px is 2 over x, so we have 2 over x over x, okay, x and x cancel, we have 2, okay. So this, when we replace, I mean, this is constant, so it's analytic when x equal to 0. Okay, for whatever it is, this function will be 2. Okay, we have value. Okay, the same thing for x minus x naught square. So x naught is equal to 0. So this one will be x square and qx equal to 1. Okay, x square times 1 is x square. Again, when x equal to 0, this function is what is defined. Okay, so again, this function is analytic when x equal to 0. So we can conclude that x equal to 0 is a regular singular point. Right? Do the same thing as before. So why x equal to these summations? Because x not is equal to 0. So we have this. And then y prime as before equal to n plus r cn xn minus n plus r minus 1, whereas y double prime equal to n plus r minus 1, okay, cn xn plus r minus 2. Okay, both all start with 0, the index. Okay, so now x, okay, xy double prime plus 2y prime plus xy equal to 0. Okay, so you replace here the y double prime, here is y prime, here is y. Okay, use the same procedure as before. Bring this x inside. Now become xn plus r minus 1. Okay, okay, minus 2 become minus 1 because of this x. Okay, you multiply this term with x. You bring 2 inside. Becomes 2n plus r, cn xn plus r minus 1. You bring this x inside, so now become xn plus r plus 1. Okay, and then again, okay, so the first summation involving xn plus r minus 1. Okay, the second one also involving xn plus r minus 1, whereas the last one n plus r plus 1. So it's up to you. You want to change. If you want to change this to n plus r plus 1, you got to change both summations. So it's a good idea. You only change the last one, but the first and the second remain unchanged, because you try to avoid changing as many as summation. You want to choose the one that we change the least. Okay, in this case, this one, the third one. Okay, the third one, we need to change the power to x n plus r minus 1. So you got to replace this n with n minus 2. Okay, that's why you have n minus 2 equal to 0. That means n equal to 2. Okay, this one n minus 2 equal to 0. So n now start with 2. So cn minus 2. So x n minus 2 plus r plus 1, we get n plus r minus 1. Okay, the same concept, right? Now, okay, the power are the same. Okay, the power are the same, but the index are not the same. This one start with 0. This one start with 0. This one start with 2. All right. So we need, okay, now for the first and the second summation, we got to substitute n with 0 and n with 1. Okay, so we do this. Okay, when n equal to 0, so we have 0 plus r, which is r. Okay, 0 plus r minus 1, c naught. Okay, c naught. And then we have x r minus 1, because n is equal to 0. And when you replace, okay, then you replace n with what? N with 1. We have 1 plus r, and then 1 plus r minus 1, okay, which is r, okay, and then c1, x1 plus r minus 1. You just replace first. And then for this one, you replace, okay, replace, okay. Now for this one, after this, it will start with what? With 2. With 2. Okay. And then this, okay, this one is I make it, I simplify the work. Okay. So now we replace n with 0 here. So we have 0 plus r is 2r, and c0, and then x r minus 1, and then now start with 1, replace with 1. We have plus 2, okay, 2, 1 plus r, c1, x1 plus r minus 1. Okay, and from now on, all these summations start with 2. And that's why I put 2 there. I combine this, I put this inside. Okay, put this inside, and then this inside here. Okay, all this inside. Okay, all multiplied by n x n plus r minus 1. Okay, okay, now simplify this, all this term. Okay, it will be what? This will be r square. Okay, this will be this. Let me see. Here should be r square. This one should be minus, right? This one should be minus. Okay, should be here. No, 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 no. Okay, do it again. Okay, here. Combine this, we combine this. Okay, this and this we combine. Okay, this one will be r square minus r, and then plus 2r. And that's why we have r square plus r. Okay, this one r square minus r, and then plus 2r. It will be r square plus r, which is this. Okay, so we combine these two terms. Right? If I plus cn minus 2, okay, xn plus r minus 1. All right, and then you can simplify this. Okay, now you can simplify this later. Okay, now this will go to 0 here. Okay, this will be 0 equal to 0, because we know we have before this we learned that C0 will not equal to 0 based on the theorem. Okay, the same thing here, C1 will not be 0. So this will be 0 if and only if r square plus r equal to 0. This implies that r equal to 0 and r equal to minus 1. Okay, for this expression, so r square plus tr plus 2 equal to 0 imply that r equal to minus 1, r equal to 2. So r will be 3 different value, r equal to 0, r equal to minus 1. So this one is taking care of this. So r equal to minus 2. We have 3 value, distinct value of r. Okay. Now for this, we need to simplify this. Okay, we need to simplify this. Okay. This will equal to 0. So this equal to 0. Okay. Now we simplify this. N plus r minus 1 plus 2 equal to n plus r plus 1. Okay, and then times Cn, and then plus Cn minus 2 equal to 0. From here we can establish the relationship between Cn and Cn minus 2. So Cn equal to minus Cn minus 2 over n plus r times n plus r plus 1. Okay, I think some of you guys have already done this. So for when r equal to 0, Cn will be minus Cn minus 1 over n plus n times n plus 1, because r now becomes 0, right? N equal to 2, 3, and 4. Again, you replace n with 2. You want to get first few terms. Okay, you have when n equal to 2, C2 equal to minus C0 over 6. Okay, and then when n equal to 3, okay, we have C3 equal to minus C1 over 12. Actually, this one is 2 times 3. This one is 2. This one is what? This one is 3 times 4, right? 3 times 4, right? And then probably Suting can express this in general terms. Okay, I think you are good at this. You can do. You can go ahead. Okay, and then n equal to 4. Okay, C4 equal to C0 over 120, right? And then you have Y1. Okay, this one is will be Y1. Okay, corresponding to R equal to 0. Okay, and then Y1 depend on C0 and C1. Okay, and then you can break them up into two. Okay, one is depend on C0, one is depend on C1. Okay, when R equal to minus 1, now Cn equal to minus Cn minus 2. So you replace here n equal to 1, n equal to minus 1. Okay, so you have r minus 1, and it's 1 times r minus, it's minus 1 plus 1 is equal to 0. Okay, and that's why you have this, right? And then get few terms for n equal to 2 and so on. So we have this C2 equal to minus C0 over 1 plus 2, times 2. And then here, okay, you have when n equal to 3, C3 equal to minus C1 over 2 times 3, which is, this one is 3 factorial, this is 4 factorial. Okay, and this one is easy to see. But again, but this one C0, this one C1. If this one is C1, then no problem. You can do general terms, right? It's easier. Okay. So when n is even, when n is even, C2, okay, it depend on C0. When n is odd, like C3 is depend on C1. Okay, even depend on C0, odd even depend on C1. Again, okay, this correspond to Y2. Okay, Y2. Now remember here, okay, now we got to replace here, Cn xn plus r. R now equal to minus 1. Okay, don't put Cn xn. Okay, because our y now become what? Y become Cn xn plus r. In the previous method, this one Cn x power of n. For Frobenius, n plus r. Okay, okay. For y1, and we have Cn because what? R equal to 0. Okay, for y2, r equal to minus 1. Here will be xn minus 1. Okay, don't be careless on this one. Okay, okay, n minus 1. So we have this. So y2 equal to, we just replace the coefficients. We can break into 2. Okay, and then depend on C1, C0, and the other one is C1. Okay, now when r equal to minus 2, okay, when r equal to minus 2, okay, we replace this r with minus 2. Okay, so we have n minus 2. So n minus 2 plus 1, we have n minus 1. So n minus 2 plus 1, we have n minus 1. For n equal to 2, 3, and so on. All right. When n equal to 2, when n equal to 2, we have what? We have C2 equal to minus 2 here. Okay. 2 minus 2 is equal to 0. So minus C0. Here we have 2 minus 2, which is 0. Okay, 0 over 2 minus 1. So we have minus C naught over 0 plus 1. Okay, 0 times 1, 0 times 1 is 0. So minus C naught over 0 is undefined. Then you stop. Do not proceed. Okay? So when R equal to minus 2, we don't get any solutions. Okay? We don't get any solutions. Okay? Or if you get this one, okay, when n equal to 2, C2 equal to, you got something here, not divided by 0. But when n equal to 3, we have something over 0 undefined. You stop. Okay? So there is no solution for R equal to minus 2. So in this case, although we have 3 values of R, but when although we have 3 values of R, but when R equal to minus 2, we don't get any solutions. Okay, and that's why we have R y equal to a y1 plus b y2. Okay, there is no y3. Okay, because there is no solutions. Okay, so the same thing, you just plug in y1 and y2. Okay, and then this. Okay, you got this. If you can write this in general form, that is even better. In summation, that even better. Okay, all example that we have shown you, okay, we're dealing with x not equal to 0. The question now, what if x not equal to 0? Okay, you use the same process as before, but then now, okay, for example, when x not equal to minus 1, yx now will be this. It will be, okay, will be summation Cn x minus x naught n plus r will be Cn x plus 1, okay, n plus r. Okay, because x naught now becomes minus 1, x minus 1 become x plus 1. Okay, so it's no longer x power n plus r. Okay, this one is more complicated, right? And then the same for y double primes, y primes. So y prime will be n plus r. You see n x plus 1, n plus r minus 1, whereas y double prime equal to n plus r, n plus r minus 1, Cn summation, right? Cn x plus r, n plus r minus 2. The same thing as before, except now we have x plus 1, x plus 1. Okay? So if you know this, if you understand the concept, it's much easier for you. Okay, don't memorize question by question. Okay, you got to understand the basic concept. The rest will be easy. Okay, so I think now, okay, we conclude, okay, chapter 4. Okay, that's the end of chapter 4. Okay, so any question before I proceed? Okay, guys, okay, don't make like careless mistake. For example, for each one of these, you have points. For n equal to 2, you find C2, you got some point there. You got some mark. N equal to 3, you got some mark. If you got is wrong, you will lose a lot of marks. Okay, student lose a lot of mark here. Here, okay, when this is wrong, this one also will be wrong. Okay, because it depends on C. When you got the wrong C, the answer will be wrong. Okay, so the mistake will be inherited from the previous one. Okay, it's depend on the previous one. Okay, and that's why in this topic, okay, if you do careless mistake, you will lose a lot of marks. Okay, it depend each one of these you got point. Okay, so do not do careless mistake. All right, any question before I proceed? No questions? Abdul Rahman, are you there? Abdul Rahman, are you there? No. Tan, are you there, Tan? Tan, are you there?
Yes, sir.
All right. How about Sharul Azmi? Are you there?
Sir, I got question.
Which
If,
okay, which one, Tan?
Stop. Up.
Up
Yeah, here. For the
here.
statement. How do we know for n equal to 2, 3, 4, but not 1? Oh,
Again, Tan, say it again.
how do we know the n starts from 2, 3, 4?
Here, from here, Tan, from here. Here, Tan, of this summation and start from 2, right? Here.
Okay.
See, in the previous one, let me show you the previous one. Here, okay, for here and start with 1. Why 1, Tan? Because okay now. Okay now let me see here because here in this thing. Let me see here. We go here. Okay. For example, here and start with 1 because of this. Okay, it's depend on this index, Tan. Okay, are you okay? Depend on this. Okay, Tan?
Kalau
Ya. Siapa dia ni?
kalau macam kita Fat ni Nadia, kalau masa kita nak tahu kena buat sampai nombor berapa tu macam mana?
Okay. Kalau you dapat pattern, okay, tujuan dia buat itu dapat pattern. Okay, so you buatlah few term sampai sorry, this one will be C5, right? This one is C5. C5. This one is C5. Okay, tujuan dia Nadia kita nak dapat pattern. Kalau kita dapat pattern, just kita buatlah sampai macam 5 ke 6 ke macam tu, right? Few terms lah Nadia. Okay, actually tujuan dia nak dapatkan pattern. Macam ni kita dapat pattern kan? 2 and then 2 times 3. Okay, 2 times 3 times 4. This one 3 factorial, 4 factorial, 5 factorial. Okay, kalau you dapat pattern kat sini dah, you tahu dah and then you stop. No need to proceed. You can stop up to here. Okay, or here. Right? So you dapat pattern. Okay, kalau tak dapat pattern tu lah you go on like you buatlah 6 terms ke, okay, 6 ke up till C6 and then you stop. You cannot go like macam C10, too much time. Dalam test too much time. You stop lah dekat C5 ke C6 macam tu. Okay, Nadia? Dia tak ada rule of thumb, Nadia. Okay? Did I answer your question, Nadia?
Yes, sir. Thank you.
Okay. Any other question? Any other questions? Okay. So this is your last topic. Okay. So now, so we are left behind. I mean, in terms of syllabus, in terms of, because I supposed to teach you to give lecture on Laplace, okay, this week. Okay, so okay, I will continue with the last topic. Okay, even though you are focused on your third test, okay, I also have to finish our syllabus. Okay, I have no choice. Okay, so tonight I will introduce you the basic concept of Laplace transform. Okay, again, what is the use of Laplace transform? Again, we want to solve higher order ODE. Okay, so in this chapter, you learn how to solve ODE. In chapter 2, you learn how to solve first order. In chapter 3, 4, second order. And chapter 5, you can solve second order, third, and so on, higher order. Okay, we use Laplace transform to solve higher order ODE. Okay, but we focus more on second order. But we can solve also third order and also 5th order and so on. Okay, so this is another technique to solve higher order ODE. Okay, so what is Laplace transform? Okay, Laplace transform, okay, Laplace transform of ft, okay, of ft, a function of ft, we denote by this, okay, LFT, Laplace transform of ft, okay, Laplace transform of ft, okay, is defined as what? Semi-infinite, okay, semi-infinite integral. What do you mean by semi-infinite? Okay, it's defined as this, okay? Integral t from 0 up till infinity. Okay, this is semi-infinite. We start from 0 up to infinity, upper level. Okay, if we start from minus infinity to infinity, this one is infinite integral. Okay, if from minus infinity to infinity, we call it infinite integral. But if consider from 0 up till infinity, we call it semi-infinite integral. Okay, it's defined as, okay, integral 3 from 0 up to infinity ft. We multiply this ft with e to the power of minus st dt. Okay, we multiply this with e power of minus st. We integrate respect to t. Okay, t in this case is what? Is the independent variable. Okay, so what is s? S is positive. Okay, s is positive and large enough to guarantee that okay, this integral converge. Why is it so? Okay, why s to be positive? Why not negative? Why s to be large value? Why cannot be small value? Okay, you got to think about this, right? Because when s is positive and large, okay, e minus st you can rewrite as 1 over e power of st. And 1 divide a very huge number will approaching 0. Yeah, you relate these two limit. Okay, so you got to understand this concept. Why this is positive? Why it's large? Okay, in order for you to understand this. All right. Now, after you integrate this function ft times e minus st respect to t, you will evaluate. Okay, you will evaluate t with 0 and infinity. Okay, you will set the value of t with this. Right? So now, when you evaluate this, all function now in terms of s. Okay, after you evaluate this integral, okay, you replace t with 0 and infinity. Okay, okay, and then this function now in terms of s. Okay, so when you take the Laplace transform small of ft, you get a function of s. Okay, t there, f there, Laplace. So later on, you will learn inverse Laplace. Okay, this one is Laplace transform, and then after this, inverse Laplace transform. Okay, so Laplace transform a function of ft, you get a function of s. Okay, this one small, this one capital. This notations. Okay, now having said that, okay, so now ft can be anything. Okay, ft can be anything. Example number 1. Okay, ft is a constant. Okay, ft equal to a. So what is a Laplace transform of a? Because f of t equal to a, what is Laplace transform of a? Okay, it's equal to, okay, you use the definitions. So you replace this ft with a. Okay, that's why you have a there. Okay, you replace ft with a. Okay, and then here ft with a. So you have a e power of minus xt dt. Okay, that is the first step. Replace ft with a. Okay, now, of course, we cannot substitute t with what? With infinity, because this is just a big number. We don't know what is infinity, right? And that's why we got to use the concept of limit. Okay, so to integrate t from 0 to infinity, okay, of this of a e to the power of minus st dt is equal to, you integrate, okay, from t equal to 0 up to n, but n, this one is approaching infinity. Okay, but then okay, this concept, right? All right, now Zahrudin, are you there, Zahrudin? Zahrudin, are you there?
Yes, sir.
Can you understand this step? From here to here.
No, sir. I don't understand.
Okay. Yang ni from your yang ni from your calculus 1, I think.
Calculus
2, class 2.
One.
Okay, 1 or 2. Okay, this, okay. Buat macam ni. Buat macam tu. Copy here, I put kat sini. Okay, katakan dalam calculus 2 lah macam tu. Okay, tak ada apa. Okay, and then yang ni you buat macam tu, and then sini you buat S, ini constant 2. Ke 3 macam tu. Macam mana you integrate this?
Integrate this.
Okay, so A, right? A, nak ubah A, buat A juga. Okay, and then you integrate E minus power of minus 3t with respect to t, dapat apa?
Negative 3.
Dia dapat apa? You dapat apa? You dapat apa dulu? Integrate dia dapat apa?
Integrate kita akan jadi ni.
Jadi apa?
E power of negative 3t.
Okay, you remain, you tak ubah, you tak tukar. You tak ubah apa pun. You tak ubah macam tu. Copy saja. And then yang bawah ni you kena differentiate minus 3t with respect to t. Dapat minus 3. Right? Okay. Yeah. Kalau you okay. Buat ni copy. Nak bagi you faham, okay, copy. Contoh kalau macam ni. Okay, kalau y. Okay, y equal to this. Okay. And then you differentiate dapat apa?
Differentiate dapat negative 3ae power of negative 3t. Okay,
you nak cari y prime. Okay, anak saya question nak cari y prime kat mana? Okay. And try dy dx. Okay, dy dx atau y prime. Okay, y primes. Okay, equal to sama juga dibuat. You ambil copy semua tu. come to, okay, sama. Cuma sekarang ni you differentiate minus 3t, you darab, ya. You darab dengan minus 3. Okay, minus 3. Okay, itu kalau A dapat yang macam ni. Okay, alright. So kalau yang ini you kena bahagi. Okay, bila you integrate you kena bahagi macam tu. Okay?
Okay.
Okay, siapa tak faham lagi?
Thank you, sir.
Oh, you're welcome. Matematik ni sebenarnya senang sangat-sangat. Okay? Kenapa I kata senang? Sebab once you grab the concept, soalan apa pun you boleh buat. InsyaAllah. Okay? You tak perlu baca teruk-teruk, ya. Other subject you kena baca teruk-teruk. Macam IT umpamanya, it keep changing. Okay? It always keep changing. But in mathematics, the concept remain unchanged. So that's why when you understand the concept, that's it. Okay, the rest should be okay. Okay, now, so you integrate this. Okay, you integrate this, you will get A e minus st over minus s. Of course, you need to evaluate this. T from 0 till t from 0 up till n. Okay. Okay. First, you substitute. This one is t, right? You substitute t with n first. So you have a e minus sn over minus s. Okay, and then you minus. You substitute t with 0. So a e minus s times 0 over minus s. Okay, any question yang ni? Step by step. Siapa ada masalah yang ni? Okay, you just replace, you just substitute t with n, okay, and then you substitute t with 0. Okay, why did I put t there? I tak mau takut you silap, you buh s sini salah ya. Okay, because t is dependent variable. Okay, that's why I tak nak you confuse. I put macam ni supaya you tahu, you hanya akan replace t saja. S remain as it is. Okay. So we have this, all right. Now, okay. So a times e to the power of minus sn over minus s. I can bring this power down. Okay, this is the same as 1 over e power of sn. Tengok, kuasa sekarang berturun, kuasa dah hilang. Negatif jadi positif. Okay, the property of exponent. This is equal to 1 over e power of sn, which is this. Okay, and then this one, a e power of s times 0. So e power of 0 is equal to what? 1. This one equal to 1. And that's why we have a over minus s. No need to bring this down, because we get 1 as well. Okay, so this one will be 1. So a over minus s. Okay, so now you have a limit. Okay, as n goes to infinity, a over minus s times e power of sn, okay, minus a over minus s. Okay, now as n goes to infinity, this term will goes to 0. This term will goes to 0. Why? Why this term will goes to 0? Because a is a constant divided by, when n goes to infinity, this term will be goes to infinity, will be huge. E to the power of a very huge number will be very huge. Okay, any constant divided by a very huge number will goes to 0. So this term will be goes to 0, and this one remain unchanged because only n goes to infinity. This remain unchanged. So minus a over minus s. So minus become plus. That means a over s. So we have a over s. Okay. So Laplace transform of a is equal to a over s. So the function now is in terms of what? It's a function of s. Okay. So far, okay, so far so good. Can you guys still follow me? I got a few more example. Okay, so this when when ft equal to a. Okay, let's do it. Let's do this when ft is equal to t. Okay, do the same thing there. Okay, here is what you replace this ft with t. Okay, now okay, this we replace with limit. Okay, n goes to infinity. This one n. Okay, here and then here we need to use what? We need to use parts by parts. Okay, why? Because t appear here and also there. Okay, we use part by parts to let u equal to t. The rest will be dv. So dv will be e to the power of minus st dt. You didn't appreciate u, you got du. So du equal to dt. You integrate dv, you have v. V again equal to minus e to the power of minus st divided by minus s. Okay, you integrate this, you will get v equal to, integrate this, you will get minus est. So e power of minus st divided by minus s. Okay, and then you use uv. Okay, uv. Okay, this equal to uv. So uv equal to t times minus est divided by minus s. You have this. Okay, uv minus integral v du. Yeah, remember you use part by parts. Okay, so integral now v equal to this and then du equal to dt. So v du dt and then you evaluate t from 0 up till n. Okay, so we simplify this and then you integrate e minus st over minus s. Integrate this, you will get minus est divided by minus s times minus s. Okay, y s squared. So you integrate this, we will get minus est divided by minus s. So minus s times minus s will give you s squared. Siapa yang tak clear yang ni? Okay, because we integrate this, we will get minus est and then over minus s times minus s give you s squared. All right, and then you evaluate t from 0 up till n. Okay, we simplify these expressions. Okay, we take this thing out. So minus est over s squared, we take that out. Okay, and then multiply st. Okay, we get the first term. Okay, minus e to the power of minus st divided by s squared times st will give you this first term. Okay, to get the second terms, we multiply minus st over s squared with 1. Okay, 1 times this will give you the second terms. We just rearrange the order, right? And then we substitute. Now we substitute t with n first. So this will be minus e minus sn over s squared. St become sn plus 1. Then minus, when we substitute this term with 0. So become minus e minus s times 0 over s squared times s times 0 plus 1. Okay, and then we simplify this. We can bring this down. Okay, this will be minus 1 over s squared times e power of sn. Okay, this one will be 1 over e sn. And then times sn plus 1. And then minus, okay, minus, okay, this one, okay, e power of, okay, e power of 0, this one e power of 0 is equal to 1. Okay, and then 1 over minus 1 over s squared. Okay, and then s times 0 is equal to 0 plus 1. So you have 1. That means you have 1 minus 1 over s squared times 1. Okay, and that's why you have this. Okay, this. Okay, because this one is 0, this one is equal to 1, this one is minus 1 over s squared. And then these terms when you take the limit, this term will goes to 0. Why? Because this n is very huge. The e power of huge number become very huge number. 1 divided a very huge number will goes to 0. So this term will goes to 0. I mean, we have 0 minus 1 over s squared times 0 plus 1. I mean, minus become plus. We have 1 over s squared. So Laplace transform of t is equal to 1 over s squared. Okay, remember now, all the function now in terms of s. This is a capital F of s. Okay. And then for third example, okay, let's say, okay, this is EAT. It become more complicated, okay, EAT. So do the same thing, you replace FT with EAT. So this one will become EAT, e to the power of minus ST, use the definitions. Okay, EAT times E minus ST can be written as E to the power of AT minus ST or A minus S times T. Okay, this will be E power of AT minus ST or equal to E power of A minus ST. Okay, again, okay, this one. Okay, you integrate E power of A minus ST. Remember, this one is a constant. This one is a big number, constant, right? So this one treat as a constant because this function we just want to integrate with respect to t there, So this will be, this is treat as a constant. So it will be E power of power of A minus ST. Okay, you differentiate A minus ST with respect to t, we have A minus S. So we over A minus S. Because you differentiate A minus ST, you will get A minus S. So divided by A minus S. Okay, and then you evaluate t from 0 up to n. So you replace t with n there, and then 0 there. Okay, and then remember, okay, this one, when s greater than a, okay, when s greater than a, that means here a minus s will be what? And s greater than a minus s is negative. Okay, a minus s negative. Okay, you can bring this down. Okay, it will be a very huge number in the denominator. And then when Sn goes to infinity, this term will diminish. Okay, will be eliminated, will tends to 0. Okay, this one term will to 0 because this term is negative. You bring down huge number, this term will goes to 0, and then this will be minus. Okay, e power of a minus s times 0 is 0. E power of 0 is equal to 1. So 1 over a minus s. So we have minus to 0 minus 1 over a minus s. Okay, or this we can express as 1 over s minus a. Okay, because minus 1 over a minus s is equal to 1 over, this one you multiply with minus, we have s minus a. Okay, when s is greater than a. Okay, so the Laplace transform of e to the power of at is equal to 1 over s minus a. Okay, this is when you use the definitions. Okay, you get the Laplace transform when you use the definitions. These definitions. Okay, definitions. This. But luckily, you don't need to do this unless you are told to prove using definitions. Normally, you are given the table, okay, Laplace table. Okay, so this is a function f of t. This is Laplace transform. Okay, this table ft. Okay, the table of ft, and table of fs. Okay, fs is a Laplace transform of ft. Okay, so we have this table. Okay, this table function ft, and this one is fs. Fs is Laplace transform of ft. Okay, when ft equal to a we have a over s. Okay, this from the table. Okay, this is by using the definitions. Okay, when ft equal to a, Laplace transform is equal to a over s. Okay, you use definitions. Okay, this is from the table. Okay, the table is constructed from the definitions. Okay, so when ft equal to a, this one is a over s. When a equal to 1 here, that's why you have 1 over s. This is a special kind when a is equal to 1. Okay, so Laplace transform of 1 is equal to 1 over s. Okay, when we have t here, okay, Laplace transform is 1 over s squared. This is the table. So we have done this before. When f is equal to t, Laplace transform of f of t is equal to 1 over s squared. When ft equal to t, Laplace transform of t is equal to 1 over s squared. From the definitions here, Laplace transform of e power of at is equal to 1 over s minus a. So from the table here, you got the same thing here. Okay, this is we get from the definitions. Okay, why put the table? Okay, so we have this table so that it's easier for you to refer. No need to do by using the definitions. If you use the definition, we will get the same thing. Okay, but it will what? It will require a lot of times, and that's why we need table there. Okay, so table there. So now you know a little bit about Laplace transform. Okay, you know the definition of Laplace transform. Okay, Laplace transform of f of t is equal to integral of ft times, okay, you times with e power of st, can you integrate respect to t, semi-integral, and then you replace this semi-integral with limit, with this limit. Okay, and then to save times, you are given the table, and then you can use this table to find the Laplace transform. Okay, so after this, I will teach you how to find inverse Laplace transform, and then we can solve any higher order ODE using Laplace transforms method. Okay, I think that's all for now today. Okay, I hope you are still not sleepy. All right. Thanks for your times. Thanks